Now let us go to another example and see what is going to happen in that. So the next example is again of a complex, octahedral complex, which has a coordination number 6, and in this case instead of cobalt we have chromium. First of all, again you need to determine the oxidation number of chromium. So the oxidation number of chromium will be here X plus 6 into NH3 will be equal to plus 3. So that's X is equal to plus 3 because NH3 is 0. So oxidation number of chromium is also plus 3. Next, you have to determine the electronic configuration of chromium 3 positive. So chromium 3 positive, first of all, chromium has an atomic number of 24 and its electronic configuration is argon 3d5 4s1. So 3 positive, chromium 3 positive means that it has lost 3 electrons. So Cr3 positive is going to be 3d3. So if you make the d orbitals, okay, this is 3d, 4s, 4p, 4d. Now let us fill in the electrons. So in 3d there are only 3 electrons, okay, and now these electrons are not going to pair up because you already have 2 empty orbitals present on d, so there is no need for pairing up. And you have 6 NH3, so the lone pair, which are the orbitals which contain the lone pairs, they are going to overlap with the empty orbitals of the chromium metal ion. So this is NH3, this is also NH3. Again we have NH3, NH3, NH3 and NH3. So again the configuration that we got was D2sp3, which is an inner orbital configuration. Even though there was no pairing of electrons, but still we got a D2sp3 configuration. Next we come to another example. Again we are going to do an octahedral complex. So in this case the cobalt is the same, what is changing is the ligand. First of all, again you have to find the oxidation number of cobalt. So that's going to be X plus 6 into F is equal to minus 3. So X minus 6 is equal to minus 3. So X is equal to plus 3. Here it is minus 6 because fluorine has a charge of minus 1. So X is equal to plus 3. Then the oxidation number of cobalt is equal to plus 3. So cobalt exists as a 3 positive ion. So in the next step you have to find the electronic configuration of CO3 positive. So we know that the electronic configuration of CO3 positive is Ar3d6. So let's make our d orbitals. That's 3d. And 4d. Now we will fill in the electrons which are of cobalt. So that's 6, 1, 2, 3, 4, 5 and 6. Now d orbital does not have any empty orbitals present, okay. So if pairing needs to happen or if overlap needs to happen, then pairing has to occur. But the ligand here is fluorine, and fluorine does not provide the adequate environment for pairing. With fluorine, pairing does not occur. So 3d electrons, they will not get paired, and because they are not going to get paired, therefore there will be no empty available orbitals on the 3d. So you will have to make do with the orbitals of the 4s, 4p and the 4d. So the orbitals which contain the lone pairs of the fluorine atoms, are going to overlap with the empty orbitals 4s, 4p and 4d. So that's one fluorine ligand. This is another F negative, another F negative, so now this is sp3d2. Outer d orbitals are used for this, therefore this has the configuration sp3d2. Next we come to a question. So the question asks you the complex ion which has no d electrons in the central metal atom is, and it is given you a bunch of options. So first option, let's see the first option. For these type of questions, first you need to calculate the oxidation number, and from the oxidation number you need to calculate how many electrons are present in the d orbital. In this case, we can take the Mn as x plus 4 into the charge of oxygen is equal to minus 1. Oxygen has minus 2 charge, so that's x minus 8 is equal to minus 1, which gives you x is equal to plus 7. And manganese originally had the electronic configuration 3d5, argon 3d5, 4s2. So if manganese is present as Mn7 positive, that means 7 electrons have been taken away from manganese. So if 7 electrons are taken away from manganese, that leaves 0 electrons in your 4s orbital and 0 electrons in your 3d orbital as well. So manganese is the one which has no d electrons, that is this complex will have no d electrons in the central metal atom. Let's see if it's true for the others also. So this we already have done. In this we got a CO3 positive, and we know that it has the configuration Ar 3d6. So no, it does not have 0 d electrons in the d orbital. In your third, this is x plus 6 into Cn is equal to minus 3. So x minus 6 is equal to minus 3, which gives you x is equal to plus 3. That means iron is present as Fe3 positive in this complex. Iron originally has an electronic configuration of Ar 3d6 4s2. This is iron's electronic configuration. So Fe3 positive means 3 electrons have been taken away from iron. That means 2 electrons will be taken away from 4s and 1 electron from 3d, which leaves you with 3d5. So no, this complex also does not have 0 d electrons. The last one is x plus 6 into 0 is equal to plus 3. So x is equal to plus 3. That means chromium exists as 3 positive. And we know chromium when exists as 3 positive, it has the electronic configuration Ar 3d3. So our correct option is the option A.